Hi students, this is Ms. Medina, and in this video we're going to talk about the three types of solutions for linear equations. Alright, the first one is the one that we're most used to, is when you have one solution, and that is when your final answer results in the form of x equals a, with a being some sort of value, okay? And so this is the case where there's only one real number that's going to make this true, or one solution. So let's do an example. So you have this and you're solving. I see parentheses, so you're going to distribute the 2. You're going to get 2x minus 6 plus 9. So right now we're just keeping all the terms that we haven't touched, okay? Well, we might as well rewrite this because we have the x and then you have the 5 minus 1. Let's see on this side. Negative 6 plus 9 are like terms. If you put that in your calculator, negative 6 plus 9 will give you a positive 3. So this becomes 2x plus 3. And if you look at the right-hand side, positive 5 minus 1 will give you 4, plus 4. Okay. So now we're going to move the variables to the left and the constants to the right. Okay, so we'll subtract x on both sides. So we have x plus 3 equals 4. And we're going to move the constants to the right-hand side. So minus 3, minus 3. X equals 1. There you go. See? X equals 1, x equals something, one solution. Compared to infinite solutions. In infinite solutions, the final answer is going to be right after you move your variables, they're going to cancel out and you'll be left with an equality. Something equals the same thing. So that's how you know that you end up with infinite solutions. So let's take a look here. All right, the left-hand side is this one, right? The right-hand side is this one. All right, so let's clean this up a little bit by distributing the 2. So we have 2x plus 20 minus 17 equals, I'm going to rewrite this. I'm going to write this one first. 2x plus 5 minus 2. Is it necessary? No. Am I still going to do it? Yes. All right, so now just focusing on this one. 20 minus 17. Remember, this is just combining like terms. So it's going to give you 20 plus 3 equals 2x. 5 minus 2 is 3. Now watch. Right from here, you can tell that this is going to be infinite solutions because look at the left-hand side. And then look at the right-hand side. It's absolutely identical. You have both a 2x and you have both a 3. Okay, so if that still doesn't help, when you move the variables to the left, you see what happens? They cancel here and they cancel there, and you're left with 3 equals 3. When you end up with a equals a, or 3 equals 3, or 5 equals 5, that's an equality. That's how you know that it's infinite solutions. So how do you know when you have no solution? No solution is going to be when once your variables cancel, you're left with a equals b, which means something that is not true. Okay, so let's take a look at this. This is the left and this is the right. All right, let's clean them up. All right, so in this one and this one, those are like terms. So what's 5x minus 3x? That's 2x. All right, carrying in the 3. Now on the right-hand side, we're going to distribute that 2. So that's 2x plus 6 minus 5. Sorry, use my highlighters, okay? right, this side is okay, 2x plus 3. But the right-hand side, we need to clean this up. What's positive 6 minus 5? Right? Exactly, positive 1. Now look, just from here, you can tell that these are not going to be equal to each other. Okay? So they do have the 2x, but this is plus 3 and this is plus 1, and they're not equal to each other. So from this, you can tell there's going to be no solution. Let's say you can't tell. When we're moving the variable to the left, you'll notice that the variables cancel on both sides. And you're left with 3 equals 1. And this is not true. So that's how you know that you have no solution. Oops, non. I was going to say non-equality, but I'm just going to put not equal if I can write not correctly. There we go.